Welcome, everyone. This is our first lecture in our first unit. So, as you follow along with your lecture notes, if you notice down at the bottom right corner, that's where the slide counter will be. So, as we go through this, if you feel like you're off a bit from your notes to the lecture, that's a good place to look to make sure that you're on the right chunk of notes. So I get that black number 1 in the bottom right corner doesn't pop off of a dark purple background, but I'm not saying there isn't a way to do it. I'm just saying I haven't figured out how to change the numerical page or slide number color. But anyways, if you look closely, you should be able to see that, and it'll always keep you on task. So in this first lecture, it's kind of a hodgepodge, and we'll get through other topics that are probably more astronomy-like for you. But some of the things that we're just going to scratch the surface on with this first lecture is time and time travel. What the heck have humans even done? And we'll take a little bit of a look at budding industry of space tourism and light pollution, which seems kind of like how on earth could light pollute? But unfortunately, being here in southeastern Michigan, I found that a lot of kids need to know about light pollution before we get too far and curb some of their expectations of viewing the night sky. So here's something that I've noticed. If I just talk to kids about, like, all right, it's astronomy, what do you think we're going to talk about? One of the first things they say is stars. And I've got no problems with that response. I think that, viewing the night sky and astronomy go hand in hand. And I'll be honest with you, one of the goals that I set for this class was if a student leaves Introduction to Astronomy, they should feel pretty comfortable if they go out into the evening and they look up and it's a clear night to be able to recognize and name and bounce around to some of the major stars and constellations and asterisms and signposts that exist. So here's something, though, that I do want you to think about. When you look at those stars and you see the light from those stars, really what you're doing is you're looking back in time. And that seems kind of confusing, but think of it like this. Right now, it's daytime as I say this. There's sun leaving the Earth's surface. And it takes about 8 minutes for that sun to leave the Earth's surface, to leave the sun's surface to reach the Earth's surface. So if it takes 8 minutes for that light to go from the sun to the Earth, by the time it reaches us, how old is it? Good, 8 minutes. So let's stretch that out further. Some of these stars are substantially further away, and we'll get into distances later. But for now, just hear me out when I say they may be billions of light years away. So let's say that traveling at the speed of light, that means that it takes billions of years for that light to reach the Earth's surface. If I go out this evening and I look up at some stars that are billions of light years away, that means that it's taken billions of years for that light to reach my eyeball or to reach the surface of the Earth. So those stars, they may have exploded millions, hundreds of millions of years ago, and we haven't even seen it yet. So it's kind of interesting and it's humbling because you sort of feel small in the grand scheme of the universe. But I also think it's something that you need to keep in mind because later on we're going to start to look at some of these distances and some of these weird, almost philosophical / scientific features of the universe. So when I start to talk about looking back at stars or looking out at stars is similar to looking back in time, that gets me thinking about time travel. So here's a brief word on that.
In a universe so vast, is there any hope of us traveling fast enough so that we could visit the far-off realms of space? Will we ever be able to plant a flag in the most distant quadrants of the cosmos?
We are not going to achieve interstellar flight in our lifetime. We may be as far from reaching other stars as Leonardo da Vinci was from realizing an airplane. He had the idea, but it took another 400 years before that began flight.
Even so, it hasn't stopped scientists from imagining the theoretical possibilities of interstellar travel. One such possibility is a cosmic freak show, a much theorized portal through space called a wormhole.
So a wormhole is basically a thin tube of space that connects two very, very distant parts of space. So it's almost like a tunnel. It's a little part of space. You go in there and you pop out somewhere else in the universe.
A tunnel through space, a shortcut through the billions of light years separating the farthest ends of the universe. It begs the question of how anything could bore a hole through space.
A wormhole is basically like a tunnel through space itself that can connect one region to another region potentially very far away. So to illustrate that, we're taking space and imagining it as this two-dimensional sheet of paper. So we have a wormhole mouth that you can go in, and then the other end is a place you can go out. So you imagine a tunnel that goes into there and comes out of there. And you might say, well, it would take me longer to get from one place to another if I went through that tunnel than if I just took the direct route through ordinary space. But the point is that Einstein tells us that space and time are curved, they're flexible. So we can imagine picking up this piece of paper and curling these two regions so that they're close to each other. Then you go into that end of the wormhole, you come outside the other end, and there's a shortcut in between them in which the distance is not that much. So the wormhole provides a way that you can travel what appears to be a very long distance in a very short period of time.
And it's for that reason that wormholes have found a special place in science fiction.
If you want to write a science fiction novel, you might want to be able to get across the galaxy very quickly, and you don't want to be limited by the speed of light. So a wormhole can be a shortcut. It can be a way to get around all of the space that you have to travel through. If you believe that the speed of light really is a speed limit, you can't go faster than the speed of light. A wormhole provides you a way, maybe, to still go slower than the speed of light, but get to where you want to go much faster because the distance is much shorter. It's really just a shortcut through space itself.
A wormhole might also empty into another time. That's because wormholes are portals through the fabric of space and time. While they could theoretically link different locations in space, they could also theoretically link up different locations in time.
Because space and time are mixed up together, you could actually not only end up in a different part of space by going through the wormhole, but you could also end up in the past. You could end up in a different part of time. You could go into your own past and then come visit yourself before you entered the beginning of the wormhole.
So you can have a wormhole that goes from your living room to your dining room. They might be 5 years apart. So you enter one this year, and you come back 5 years ago. And if you take the paper with you, you've got some good chances of doing well in the stock exchange.
All right. So interesting, right? I thought so. If it didn't totally solidify in your mind the first time you hear it, don't feel like you're alone. It's kind of tricky and it's sort of heavy stuff. But one of the things that they'd mentioned that I just want to touch on real quickly is the speed of light. So we kind of say that speed of light is the fastest that anything can go. And we'll talk more about it later, but it's ballpark 186,000 miles per second. So 1/1000. Light's just traveled 186,000 miles, which works out to be not quite to the moon. Moon's about 250,000 miles away. So with that being said, if we can't come anywhere near traveling at the speed of light, but we're saying that some things are billions of light years away, that means that at something that we can't travel anywhere near that fast, you would have to travel for billions of years to get to it. There's a real good chance I won't see my billionth birthday. So we would have to figure out a way to travel substantially faster. I mean, when we talk about like jets that travel like Mach 1 or about the speed of sound's like around 720 miles per hour. So 1 hour, you've gone 720 miles. Again, the speed of light is 186,000 miles per second. So we're going to have to figure out a way to travel faster than the fastest thing if we're going to get to some of these things within our lifetime. Seems kind of crazy, right? Another thing that he talked about that's interesting is this idea that space and time are intertwined. And it's kind of tricky for sometimes kids to pull that apart or to think about it. But here's an example that maybe will shed a little light on it. If I said, hey, I'm going to be handing out $100 bills at 3 o'clock, you'd better be there. So $100 bills getting handed out at 3 o'clock, be there. I feel like most kids' follow-up question would be like, well, be where? I've got the 3 o'clock part, but where? The reverse of that would be if I said, I'm going to be handing out $100 bills in the lunchroom, somebody might say, awesome, I'd like some $100 bills. When? So you have to have the where and the when, and they can't just get pulled apart. The last thing that I thought was kind of interesting is the fellow out with the flat dimensional space, and he drew the two wormhole ends. Great example. I think it visualizes it well, but found it curious that he called one end the wormhole mouth, and then he didn't call the other one the wormhole butt. He just kind of went away from it, but perhaps that's a childlike humor in me. Let's continue on. So, turns out today is an awesome day to study astronomy. It's better than yesterday was, but it's not as good as tomorrow. And the reason being is just technology is ever increasing. And the more technology that we get, the more that we learn. And we're at this exponential rate of tech, by which I mean, if you looked at, say, right now until 1 year into the future, the amount of technology that would come out in that single year is substantially more than came out in the year before. And if you look at like down the road, a decade's worth of tech is going to be like almost the equivalent of a century's worth of tech. So technology is making astronomy very, very interesting, very, very fast. I'm always getting things through my Apple News that's just awesome new information, and it seems like everything's on the cutting edge. So it's a great time to study astronomy. So what have we done? It turns out, as far as manned missions are concerned, or by which I mean the furthest that a human has been is to the moon. And I am by no means trying to downplay that accomplishment, but keep in mind that's about a 250,000 mile trip. In the grand scheme of things, it's just this baby little jump. When we start to get more comfortable with our solar system, we'll see even trying to make this next manned mission to Mars, which looks very possible, and in the somewhat near future, it's a substantially bigger jump. But then you kind of zoom out a little bit to look at the forest through that one tree, and what you can find is, goodness gracious, we've got to go so far to get off our solar system, and technology's got to increase so much. But you got to take those steps to get there. So long story short, being to the moon, humans walking on the moon's surface, that's fantastic. That's the kind of the crown jewel of what we've done in a sense, at least as far as where we've gotten people. Mars. Have humans been to Mars? Not to my knowledge, but we've definitely sent rovers there, and that's huge. We'll get into Mars in and of itself later on down the road. There have been probes that have landed on asteroids, taken samples, and returned. And there's some people that actually theorize that mining asteroids might become a thing of the future, where it's cost effective to have something land on an asteroid, mine materials that are perhaps in short supply on Earth, and bring them back. That's insane. We've sampled comets. We've sampled the sun. That sounds a little misleading. It almost sounds like, something came up and took a little spoonful of sunshine and brought it back to the Earth. And that's not exactly the way that it worked. But when we get into those things, you'll see that it's fantastic that we can do that. And it gives us so much more information about the place in which we live. So satellites, launching probes, they almost don't even make the news anymore. I mean, SpaceX, Elon Musk's kind of offshoot of Tesla, puts Starlink satellites to give broadband Wi-Fi across the globe from satellites to the Earth's surface. And it's kind of like, yeah, I heard about that. Whereas if you stop and think about, just not too long ago, that would have been insane that we could do such a thing. So again, there's always new, interesting things coming out in the world of astronomy, and we have technology to thank for that. Space tourism. Oof, what a budding young industry. There is several space tourism or companies that are leaning towards space tourism that trade on the New York Stock Exchange, and they're in the S&P and the NASDAQ as we speak right now. One of which is Virgin Galactic. And they've taken some huge strides in trying to get space tourism as a very viable thing, to where you could take a flight into space. There are some people that theorize within the next few years, I think that's kind of a stretch, perhaps within the next decade or so, you could stay within a space hotel. So let's just take a quick look at some of this budding space tourism industry.
This is Jesse McKinley reporting for the New York Times from Albany, New York. A few years ago, the United States passed the torch of manned space flight largely to private industry.
I've had some incredible adventures in my lifetime, and space is sure to be the greatest one of all. I am going, and I hope you will be joining me.
Richard Branson took up the idea with fervor and is now closer than ever to bringing private, well-to-do clients to space.
When I tell people what I do, and I tell them about the project, most of them are interested, have a big grin, and walk away. Yeah.
Fred Curran is one of scores of space agents around the world accredited by Mr. Branson to sell the Virgin Galactic space experience. For $200,000, Virgin Galactic clients join an exclusive group of stargazers who can experience everything from centrifuge training to cocktails with fellow astronauts to be.
It's not just the time that you're going to be going up into space, but it's the quality time we're going to be spending together in anticipation.
Once Virgin gets regulatory approval to take off, the flights will last about 2 hours from wheels up to touchdown, with a precious 5 minutes in weightless suborbital space. Still, the experience should be intense.
Once they get out there, can you imagine taking off in a rocket and the G-forces on your thighs and your chest? That pressure, I get all tingly inside just thinking about how that's going to feel for somebody as they're blasting off into suborbital travel.
Virgin Galactic is not the only company that's bought into this new frontier in tourism. Several other companies are also vying to take passengers into suborbital space at a cheaper price than Virgin. At an even higher orbit, Space Adventures in Virginia has already taken people to the International Space Station. And Bigelow Aerospace in Las Vegas wants to be the first to build private stations or habitats for individuals, in case you don't want company. Of course, to realize a real future in space tourism, Virgin Galactic needs ticket buyers who are not just customers, but very, very brave pioneers.
Look at it.
Wow. This is the birth of a new industry. It is true that at some point the prices will come down. That's for another time. The initial astronauts are, in my way of thinking, angel investors. They're not going to get a return in cash. They don't get stock. Without the astronauts,
Look how sleepy he looks. Come on, buddy. Finish your thought. Well, it looks like we wound up with a little technical glitch, but you kind of get the idea. If the space tourism,
and I will have that opportunity. I'll be in the first 1,000. I know I will.
When I was a kid, I was fascinated, of course, with space and the landing on the moon and everything associated with it. I didn't have a driving passion to leave Earth. I was quite content here. But as I learned more about the project, and it dawned on me, this is actually here. This is happening. This is real. Boy, it changed everything.
Mr. Cullen has already paid his deposit, one of more than 500 clients around the world who've done so. The first passengers are expected to travel sometime in 2013 or 2014. Mr. Branson, of course, says he plans to be on the first flight with his family.
All right, so if at the end there you saw the date, that was 2012. And I apologize. I got to finagle a way to find a more up-to-date video, but that one kind of walks through the history a little bit better than the ones I've seen so far. But Virgin Galactic, their ships look substantially different than what they showed in the video now. They've had numerous test flights, and we're at a spot right now where you're looking at the beginning of a huge industry that could take place that almost seemed like science fiction not too long ago. So if you have interest in that, man, I would encourage you just to do a quick Google search of space tourism, and there's an awful lot of interesting things that are happening as we speak. So another big change, and this is kind of taking a jump back. I mean, the ancients, I think you'll find that they were very skilled in observing the night sky, and the predictions they could make were very impressive. But a lot of what happened was just based on blind faith, or when we look a little bit at the differences between astrology and astronomy. Astrology is just kind of going on blind faith, and Mars is off towards the west, so I guess I'd better go out and look for the love of my life today. That's more blind faith guessing. Astronomy, what we lean much heavier on in this class, is based in science, and it uses a scientific method. And following that simple idea that you learned about back in elementary school has been able to yield awesome results in the world of astronomy. So again, this is science-based. Are there some things that get super cool and interesting and border on philosophical / science fiction? Absolutely, and it's fun to talk about. But our ever-growing library, if you will, of knowledge is based by and large off the scientific method. So we're in southeastern Michigan. I live about 45 minutes west of here, and the night sky I get to see is substantially different than the night sky you get to see. And down the road, when we get more learned on like what you would see in different hemispheres or at different latitudes, I even mean just the night sky that I see, not so much the stars that I'm looking at, but how I get to see them. It's a better view. And the reason being is there's this thing called light pollution, and it makes it difficult to see. And the reason I bring this up is kids get excited to go outside and see the night sky. And sometimes I tell them, oh, this would actually be a pretty easy place to start off. And if you can find this, you can bounce around and find all these other neat things in the night sky. And they go outside and they can't see squat. And the reason being is light pollution. When you live in an area that's dense with people, there's a real good chance you'll have some light pollution. And basically what light pollution is, it's background light that really decreases your ability to see the night sky. So think of it kind of like this. If I was at my home and it's nighttime and we're sleeping and something wakes me up and I go to look outside my window to see what's going on outside, I know that if I turn the light on in my house, I'm not going to be able to see outside very well because it's too bright inside the house and I can't see outside very well. That's basically what light pollution is, but we're inside, the Earth's atmosphere. So take a look at the picture here, right? You've got one security light, and this is the same house, the same night, and the difference is one on the right has that security light on, and on the left does not. And that's a crazy difference in how much more detail you can see in the night sky. So all the parking lots and street signs and headlights and porch lights, all those things contribute to light pollution. And the more of those you have, the more difficult it is to see the night sky. So here is a picture from space. And here we are. Look at the mitten. There is southeastern Michigan. And you can see that there is a bright white area there. That's an awful lot of light pollution. Not the best place to go see the night sky. Cash, how come the Great Lakes are so dark? Well, it's water. There's not too many people out there right now. Look at the Upper Peninsula. Oof. If you've never been north, if you've never gotten over the bridge, please make that experience. It's fantastic. And it's almost eerie how many stars you can see at night. I really think that it's something that you should take advantage of if you haven't. But unfortunately, we're at where we're at. And if we're in a face-to-face setting, we have the luxury of being in a planetarium, and we can see some of these things even during the day. But if you go outside, and I can understand where it's a little bit discouraging, but remember, if you travel a bit, you can take this information with you and see the stars that way.
Scientists thought Comet Ison's close encounter with the sun was its last hurrah, but now there is evidence the comet may have survived.
Ison came within 1 million miles of our sun on Thursday. Astronomers thought it had been incinerated, but at least part of the comet seems to still be intact. Welcome to CBS This Morning, Saturday.
Some astronomers expected Ison to be the comet of the century due to its brightness, but expectations diminished over time. Sky gazers are facing a lot of diminished expectations lately.
The problem is light pollution, the urban glow that obscures all but the moon and a few bright stars and planets. Bob Parks wants to do something about it. He's executive director of the International Dark Sky Association. Bob, good morning.
Good morning.
How big a problem is this?
Well, it's pretty big. What we associate as good, light has always historically been associated as good, but you can get too much of a good thing. What we're seeing is just since the advent of the electric light, we want more. So over a period of a century, we've just added much, much more light to the environment to the point where now it's a real problem. We spend $110 billion annually on wasted light. It produces 750 million tons of CO2. We just need to learn to use it more intelligently.
It seems like design is a big issue here.
It is. Poorly designed light fixtures that are putting more light in the sky than on the ground are just, they're something we can't afford anymore. We used to just use light indiscriminately. We have to. Right. We have to learn to use it more intelligently.
Is there a way of measuring how fast we're essentially losing darkness in the country?
Yeah, unfortunately, we've done a lot of research on this. Up until the 50s, actually it started with Edison, with the invention of the electric light, about the turn of the century. But for the last century, we've accelerated. It didn't become noticeable until the 50s. During the 1950s, astronomers and folks started realizing that they could not see the night sky as well. Our organization was founded in '82. By that point, it was clear there was a problem. And it's growing about 3 to 5% every year.
I think people might hear the term light pollution and think, oh, that's a shame you can't see the stars well. But in your research, you have found that this affects our sort of evolutionary rhythms. This affects animals. This affects how we sleep, which are important things.
Exactly. I mean, we were the canary in the coal mines, the astronomers, the amateur astronomers. We saw it first. But the research is showing that it affects every species, and it affects species in a very dramatic way. Circadian disruption, which is something we've grown up with circadian rhythms for millennia. We have basically 12 hours a day, 12 hours of night. If we get 12 hours of night and 12 hours a day, our body is regulated well. When we start changing that, we start changing our health. And it doesn't just affect us, it affects every species from plants up to humans. But the impact is pretty dramatic. If we don't get enough dark, we don't produce something called melatonin, and melatonin can be an inhibitor of all kinds of disease. It's part of the immune system. And we're just now finding that even in, like for instance, my room last night at one of the nicest hotels in New York City it's not dark inside. I was sleeping in the light. We need to try to sleep in the dark.
Bob, how do you reverse this process? I mean, if it's a problem with lighting design and obviously urban sprawl, which continues, I mean, it doesn't seem particularly hopeful here.
Well, I have hope. We have a once in a century opportunity right now to rethink how we do outdoor lighting. In the next decade, we're going to relight the entire world with something called LED lighting.
Right.
It's starting up everywhere. New York City has announced that they're going to replace 250 million streetlights, or 250,000 streetlights in the city. This is the time to stop and rethink how we do lighting. We could reverse this trend in a decade if we do it right, but it requires government and city officials to think seriously about the wasted energy that we are spending. We could power 8 million homes with the amount of energy being wasted every year.
I thought it was fascinating to hear you say we have no sense of our place in the universe anymore
We've
either.
lost
Right.
all connection to the natural world, and the fact that, how do you expect kids to be inspired to reach for the stars when they can't see them anymore?
That's a really good
It's
point.
frustrating.
Bob, interesting topic. Thank you so much for joining us this
Well, thanks
morning.
for having me.
All right. So, light pollution, it is a problem, and it's something that can be addressed, but I don't really picture it being totally fixed. Another thing, just kind of on a side note, they made mention of somehow your circadian rhythm, where your day night time and being able to sleep in darkness. This doesn't really have so much to do with astronomy, but if you know that you look at your phone before bedtime and then you just go to sleep or you sleep next to your phone, you're really doing yourself a huge disservice. It's going to interrupt your sleep, and if you catch yourself waking up and then looking right at that screen, that's not good for your rest. You're messing with your mind, and it's thinking that we're going from day to night, and there's just quite a bit of research to suggest that's not the best way to sleep. And I know a lot of you are like old man Cash saying don't look at the old Facebook and the Snapgrams and the whatnots. I get it, but just try it for a week. See if you set your phone in the kitchen or in another room or in a drawer, if you sleep any different, and perhaps it'll help you out in the long run. So anyways, that's light pollution, and that's that. That's our first lecture. So until we meet again, be safe. You got questions, concerns, please bring them up. Look forward to seeing you next time. Bye-bye.